So, welcome once again to our discussion on natural resource economics. And in our last class yesterday, we were talking about basically optimum extraction for a non-renewable resource, right? Basically, to derive the price path, what should be the optimum price for a non-renewable resource extraction, and we said that price should be equals to marginal cost plus something additional which we have defined as marginal user cost. In this case, we said that this is basically the shadow price, the rho t, what we are talking about, the shadow price. And then in the process, after doing the mathematical optimization of our objective functional, we arrived at a condition wherein we say that total benefit of preserving the resource, if I do not preserve the if I do not extract the resource today and preserve it for tomorrow, then basically we are going to get two types of benefits. One benefit in the form of capital gain, okay, capital gain. So, the price of the resource will increase tomorrow, and then secondly, the other benefit what we also enjoy by preserving the resource for tomorrow is the stock effect on the marginal cost of extraction. More is the stock, less would be the cost of extraction. These are the two benefits, and these two benefits, if we sum it up, then that should be equals to the total interest that I would earn if I extract the resource today and put the money or revenue generated from that resource extraction in bank, and bank gives interest at the rate of R. So, total benefit then R into rho t should be equals to rho dot capital gain plus del C dot del x t. That is what we discussed yesterday. So, that means the condition what we are talking about, this is in the context of non-renewable resource. So, the condition what we have derived is total benefit R into rho t should be equals to rho dot t capital gain plus del C dot del x t. Okay. That is the total benefit that we will get tomorrow. Now, today what we are going to discuss is basically the price path or deriving the condition for optimum extraction of a renewable resource. It is going to be today's discussion. Today's discussion would be on renewable resource. Okay. And what is renewable resource? Basically, we have already defined these are naturally occurring resources, naturally occurring resources with regenerating capacity. And for an example, we can take fishery. Okay. So, what is the context? Let us assume there is a lake full of fishes, full of fish, and in a full of fish in a remote place, in a remote place, okay, okay, in a remote place. So, fishes are identical in structure, and uniformly distributed. In the lake. Okay. Right. And since the lake is in a remote place, so far the lake is undisturbed by human being. Okay. Since it is not disturbed by the human being, that means economics is not involved in this context. So, we say that this is a purely biological setting. Biological setting, right? No economics. So, in this biological setting, what we do that in this biological setting, growth of fish denoted by G equals to G of x t. So, this G equals to G of x t, this is called stock dependent growth. Okay. Stock dependent growth. Where x t is stock of fish. Okay. Right. So, this is purely a stock dependent growth that we are talking about, right. Now, if we plot this growth path diagrammatically, let us say that in the x axis we are measuring stock, okay, and in y axis what we are measuring is basically growth, which is g is a function of x t, and also the rate of extraction, okay, or sorry, not rate of extraction, rather I will say that yield, okay, y is basically yield. then the typical growth function looks like this. So, that means growth first starts with negative, then it touches here and then it is going up and again going down. So, here the idea is if x, the stock of fish is greater than x mean. What is the x mean? X mean is basically, x mean is, this is the stock, this stock, that means this is basically called x mean. So, how is this x mean defined? X mean is basically minimum stock required for the species to grow. So, this is the minimum amount. Let us say this is O, and let us say A, let us say this is P, and let us say this is X C. Okay. So, OA is basically is indicated by x mean, the amount of stock indicated by OA. If x is greater than x mean, so that means stock of the fish is more than the x mean, then only we will see a positive growth. If x, then that will indicate g of x t is positive, and if x is basically less than x mean, then that would imply x equals to 0. This is what we have to mind. So, that means at any point of time, if the stock falls below this minimum level, then we will say that the species will not grow and ultimately it will get exhausted. So, OA is the amount which is basically x mean amount of resource required, minimum stock required for the species to grow. Okay. So, what is happening here at P, at point P, growth is basically maximum. Growth is maximum, and beyond P, growth starts declining. Because if number of fish is too large, there would be too much competition for food and oxygen. That is all. Okay. So, beyond P, if grows, if the number of fish grows beyond P, then there would be too much competition among them for food and oxygen. So, as a result of which the growth will actually come down, and we assume that corresponding to this P, this is called X MSY. This is called maximum sustainable yield. Okay, maximum sustainable yield. This is called MSY. Right. Right. So, we say that X MSY is maximum sustainable yield. That is the maximum stock which is sustainable, right, maximum sustainable. So, rather than calling it X MSY is maximum sustainable yield, I would say that stock corresponding to maximum sustainable yield, because sustainable yield we are measuring here in the y axis, X is simply denoting the stock. So, X is that level of stock which actually produces maximum sustainable yield denoted by MXY. This is not sustainable yield, this is basically stock. Okay. Right. Now, at XC, growth becomes 0 again, and the growth function has two roots. What are the two roots? Two roots are X mean, this amount, this is the point X mean, and secondly X C. Okay. At X mean the function is touching x axis, and then X C again the function is touching the x axis. That is why we say that this function is basically having two roots. So, this is purely a biological setup. Human beings, they could not locate that lake. That is why the lake is undisturbed by the human being, and obviously we can understand if it is undisturbed by the human being, if they are not catching the fish. So, it is purely a biological setup, and we are considering a biological growth path, and that growth has two roots. One is at X mean, which indicates minimum amount of stock that is required for the fish to grow, and P indicates the maximum growth happening, beyond which if the fish still grows, then what will happen? There would be too much competition among them for food and oxygen, and growth will decline, and once again at Xc it will touch the x axis, and as a result of which the function has basically two roots. So, the stock corresponding to maximum growth is called maximum stock related to maximum sustainable yield, and sustainable yield is basically measuring in the y axis corresponding to the peak of this growth path.